All right, if we could have the speakers stay up here to answer questions, and yeah, we can field any questions. There's a microphone up front, I think would be best for asking questions.
Would you
Can you
mind
come
using
to
the
the
microphone?
Well, I guess I'm here first, so I'm going to ask the first question. Tom Burkhardt from the Australian Institute of Tropical Health and Medicine. The question is on the Bioko Island work. Did anyone do any work to see how consistent mosquito behaviors were? Does the indoor biting mosquito always bite indoors? Did anyone do any mark recapture experiments to see that if you capture a mosquito indoors, will it come back the next feeding cycle by indoors? And we've done this sort of work in the Solomon Islands, and we found that there was no subpopulations, that even though the mosquitoes there are extremely outdoor and early biting, they're not consistent. So if you have 2/3 of the mosquitoes that bite outdoors in one feeding cycle and you recapture them, you'll find that 2/3 took a blood meal outdoors, but 1/3 fed indoors. And the 1/3 that were fed indoors, when you release them, the next feeding cycle, 2/3 were outdoors and 1/3 was indoors. So I think if you want to look for genes associated with indoor-outdoor, you might want to make sure that that's a consistent feature of that population.
Well, that's a good question. So to answer your question first, no, we haven't done that on Bioko Island, and the reason is really a logistical one. I mean, it's incredibly hard to collect the large numbers of mosquitoes that we would need to conduct these kind of trials. I know Joe Lyons has done a similar work about a decade ago or so, I think in Tanzania, where he also did not show any consistent retrapping. But in terms of using it as a validation for our genetic data, the genetic data will stand by itself in the sense that if we consistently find genetic differences between the indoor and outdoor collected mosquitoes, those do not necessarily need to be validated by this behavioral assay.
I would disagree with that.
All right, fair enough.
I would want to know that if you're saying that there's a gene associated with a behavior, that behavior is consistent in that mosquito.
Right. So I mean, so the way to test that really would be to do functional analysis on the genes and see that if we change the gene that we see different behaviors. So we're starting to think about ways in which we might approach that. Mark release recapture approaches are also they're also messy and difficult to do. Yeah. So
Hi, Helen Pates-Jammet from Vestergaard. I have a question for Imo related to the findings from Bioko on malaria transmission outdoors. Nakul kind of touched on it during his presentation, but I was wondering if any of the findings that you have could be related to a community or mass effect due to the indoor interventions, thus also emphasizing the importance of the community mass effect.
Thank you. Mass effect seems to be what's haunting us today. Yeah, I think that's a good point. But there would be obviously individual effect as well. I'm not sure how you mean that mass effect would have in any way changed this. So we knew of individuals whether they were infected or not. We also knew whether they used the bed net when bed net coverage was quite low at that time, whether they lived in an IRS-treated house. So we adjusted for those factors. Yes, so if you reduce, I mean, I think this is what, as you say, what Nakul touched on, is that if you reduce transmission due to the impact on indoor biting, then you will have an impact on outdoor biting. But obviously, I think there's a point where that might change. If so much biting is outdoors and very little indoors, that you might lose that additional impact. I don't know whether you want to say any more about that. Comes off.
So maybe just for the last point, then that's very true that you only get this reduction in outdoor biting if you're having a big impact in mosquitoes that were originally transmitting indoors and reducing the parasite reservoir. So if they're all biting outdoors anyway, then you won't see anything.
Hi, Roy Feynman from LMVR NIH. So I have two questions that are a bit related to the first questions that were asked. First, is there any indication of mosquito transfer between the mainland and Bioko Island? And then, were there any mark release recapture works that have shown this? And then my second question is, and I may have missed this, on Bioko Island, were there any control houses where there was no intervention to compare?
All right, so two very good questions. So to get the first question first. So Marta actually has done a population genetic analysis of mosquito populations, Anopheles gambiae populations on Bioko Island and Equatorial Guinea mainland, and did not find any genetic differentiation within the molecular forms, which are now Anopheles clutzi and Gambiae sensu stricta. So that suggests that there's quite a bit of migration. Now, as part of the vector monitoring, we occasionally collect mosquitoes that we're pretty sure are migrants from the mainland. And the reason we think that is that on the island, we've analyzed, molecularly characterized about something like 25,000 mosquitoes. Now, out of those, maybe 5 or 6 are S forms, okay? And some of these S forms also carry the KDR East allele, which we not normally find on the island. So the probability of there being a hit population with KDR East, which we don't normally find, and S form, which we don't normally find, is, it's very small. So we're pretty sure that there are some mosquitoes making its way to the island. Now, when we look at Anopheles melas, a different vector on the island, we do find very strong genetic differentiation. So we suspect that some of this migration may actually be human-mediated through planes and boats, etc. And then remind me the second question. About the control houses, if there are any controls without intervention. Yeah, so unfortunately, when all these collections were done, we weren't really thinking of doing this type, of genetic analysis. So we do not have data on whether houses were sprayed that were used in the control. But what we do know is that, so one thing we were worried about, of course, was, repellency effect of the insecticide, right? I guess that's what you're alluding to. So in our analysis that we did on the increase in outdoor biting rate in Bioko Island, what we did is we looked at the ratio of indoor to outdoor biting before and after spray rounds, okay? And so since about 70% of the houses are sprayed in spray rounds, and it would be reasonable to assume that the vast majority of houses used in the collection were at least a significant proportion of those would be sprayed as well. We could find absolutely no difference so we would expect if repellency had an impact that we would see more outdoor biting right after spraying, and in fact we see the opposite. Not significantly, but there is no indication that there's repellency. Okay, thank you. Right.
John Dame, University of Florida. If you're restricting biting inside by bed nets and residual spraying, and you have more biting outside, is there an effect on the biting behavior turning more zoophagic, where there are animals and other sources of blood outside that aren't restricted any longer by being inside under nets? We haven't really done that analysis. So there's not a lot of livestock on Bioko, I believe, right? No. Dogs might be an option, maybe, but we haven't done blood meal analysis to see if they switch to different. That would further reduce the impact on malaria transmission if they were choosing another blood source.
The way we collect the mosquitoes, so we would have to do alternative trapping approaches to collect, mosquitoes that have blood fat. We've done a few blood meal analysis on mosquitoes that were collected indoors on the walls, but obviously they were human blood. But we haven't really done outdoor collection of blood fat mosquitoes to answer that question.
Has anyone done a study on the impact on biting behavior switching from one host preference to another based on selective pressure?
There are examples of switches in host. I think Sao Tome is a good example of switching of Anopheles gambiae to primarily dogs, I believe. And I think in Tanzania there was some shift in Arabiensis also that. I think it's less fixed on humans as a host, so it's more plastic in its host choice. So then you see a little bit of a shift towards other hosts there as well, I think.
So there's no Arabiensis on Bioko.
Yeah, there's no Arabiensis on Bioko, so it's. Well, I have a question for you. So you were saying that we could still control one of your models showed that we could still control outdoor biting mosquitoes with indoor approach as well. So I was wondering if you could elaborate on what that means for eliminating residual malaria transmission. Are we talking about simply having a big impact on an area with high prevalence? Or are we talking about eventually getting rid of residual malaria with indoor control measures as well?
So I think it probably wouldn't get rid of residual malaria because it would, if the outdoor mosquitoes are able to maintain transmission on their own, which it seems like they probably are, it depends on how much outdoor biting is happening, then you wouldn't be able to eliminate. It's just that if there's a lot of indoor transmission that's happening, then you get more of an effect on the outdoor transmission just because you're reducing the infection in humans. But it's probably not enough for elimination.
All right, if there are no more questions, I thank you for your attendance and have a good evening. Thank you.